Now that we have some displacement versus time examples, let's do some velocity versus time examples. So we got our little car. We're looking at stationary right now. So this car is not moving. It's just sitting there. What's that going to look like on a velocity versus time graph? So if our car is not moving, it's just sitting there, and we have 0 is our baseline. So again, X units are seconds, Y units are meters per second. That's our velocity. If this thing is not moving, and each point is telling us the velocity of that object at a given time, in a given moment of time, then this little car, we could draw points that just go straight along the baseline, right? It's not moving. It's 0 meters per second for all time periods. And what's our slope? Well, the line is straight across, but we're going to get to that in our next examples, what the slope means and what the area means. That is velocity when it's not moving, just at 0. Velocity 0. So now let's look at increasing velocity, right? We have not increasing velocity, just a positive velocity. So we have constant positive velocity here. What's that going to look like? Let's draw our X and Y axis. We have time in our X-axis. In our Y-axis, we have velocity in meters per second. And velocity stuff, again, is purple, and this is positive 1 meter per second. At all points along this line, it's going to be 1 meter per second. So whereas the displacement graph was increasing, this one's just a horizontal line. So the point is the velocity at a given time. And here our example, it's 1 meter per second at all points. So anytime you're looking at this, you could look at that and go, okay, this car is still moving at 1 meters per second. Now, what does the slope mean? The slope is the rise over the run, so it's the velocity over time, or meters per second over second, which is meters per second squared, which is acceleration, which is really cool. So the slope of a velocity time graph is telling you the acceleration. And since there's no change in velocity, the acceleration we know intuitively is going to be 0. And then just plugging in those numbers, if the rise is 0 and the run is any number, you're going to get the number 0. So the acceleration here, 0 meters per second squared. And what is the area underneath that curve? So remember, the area is the base times the height, and our base unit here we have is seconds, and our height is 1. So we have 3 times 1, the base of 3 seconds, the height of 1. And what are our units? Let's plug them in. 3 is seconds, height is meters per second. Seconds cancel, and we are left with meters. That's our displacement. So at the end of 3 seconds, we could calculate our displacement here. How far have we gone in this time period? Well, we've gone 3 meters. And we can note that underneath. So the object here has traveled 3 meters in this 3-second time period. So on this graph again, point was the velocity, slope was the acceleration, and the area was the displacement. And we have each of those down. Velocity 1 meter per second, area was 0. And let's clean it up and get our next little example now. Now we got a negative velocity. So remember our displacement here. I'm just going to turn our velocity backwards on our car. So it's like our car is moving in reverse now. Car is going backwards. So the displacement one, we had that negative slope. What's that going to look like here? We have a negative velocity. Well, we're seeing it's negative, so that's nothing in the positive. We're going to need to add a little line down here in the negatives. And at every point, it's moving negative 1 meter per second. The slope is constant on that displacement versus time graph. So here, that's a horizontal line at negative 1. So at every time period, it's moving at negative 1 meters per second. Again, the point on a velocity time graph is the velocity in meters per second at a given time. Here, it's negative 1 meter per second. So velocity, negative 1 meter per second at all times. And what does the slope mean? The slope still rise over run, which is meters per second over seconds, which is the units for acceleration. So the slope of a velocity time graph tells you the acceleration. Now, and here the acceleration is 0 because we see the slope is horizontal. And again, horizontal slope means 0. So acceleration 0, there's no change in velocity, so there's no acceleration because the definition of acceleration is to have that change in velocity. Now, what's our area that's underneath? Remember what that area is? Again, you don't have to memorize these things. You just kind of work it out by using the units. So area now, you remember what's the equation for area? I'll do the area stuff brown. It's base times the height, and the base is in seconds. The height is in meters per second. Seconds cancel, and we're left with meters. So the area is your displacement in the given time period. But notice, I forgot to, I think, note this, but you're in the negative part of the graph, so this is a negative, and I did write it down there, but you're in the negative part of the graph, so that's a negative 5 meters is the displacement. So over the 5 seconds, the car travels backwards 5 meters. That's that negative 5 meters. So while traveling 1 meter per second in reverse. And reverse simply means negative 1 meter per second. So there's our velocity time graph for that negative slope that we had at displacement time. Now let's look at our acceleration ones. Okay, our acceleration. So here's our rocket dude. He was falling down. He had that negative acceleration, force of gravity pulling down. Then he turns on his little boosters. The force of gravity is going up. The acceleration's going up. Sorry, not force of gravity. The force of the rocket is pushing him up. And the velocity's still going down, though, at the beginning. So what does the velocity time graph now look like for this one? So at the very beginning, he had a big negative velocity. All right, so if we look at positive and negative velocities here, at the very beginning, he has a very big negative velocity right when he turns on his rocket boosters. And by time 0, or by time, what do I have that there, 4 seconds? At 4 seconds, his velocity is 0. He stops. And by time 8 seconds, I had those mislabeled, at time 8 seconds, he's now moving back in the positive direction. So at the beginning, he had that big negative velocity. At 4 seconds, he was moving 0, so now we're at 0. And then at 8 seconds, he had that big positive velocity. So we'll show what's going on there. He's not moving, and then he's moving upwards by that last point. So cool little rocket man. You should wear a helmet, little rocket man. Gonna bump your head. Okay, the point. It tells the velocity at a given moment in time. So every point along this graph is going to tell us what a given velocity is. And here we had the big negative velocity at the start. By 4 seconds, he was stopped, and then he was moving upwards by 8 seconds. He had that big positive velocity. And what does the slope mean? Well, the slope gives the acceleration. We remember it's meters per second over seconds. And we have a positive slope, which means it is a positive acceleration this entire time period. And we can just double check that knowing the units, that meters per second for our velocity over time period of seconds. Meters per second over seconds is meters per second squared, which is acceleration. Acceleration is meters per second squared. And we go to the right when we're finding the rise, and we go upwards when we're finding the run. So that's positive, positive. So just showing that that is a positive slope there. Now, what about area? Area gives the displacement up to that moment in time. Okay, gives the displacement up to that moment in time. So the first little section from 0 to 4 seconds, we have a negative area. That means he was going backwards or downwards. And then the second half from 4 seconds to 8 seconds, now he's moving upwards. So we have a positive displacement. So the first little bit, again, he's moving downwards, then he starts moving upwards. So net displacement is 0 meters because he started at 10 meters, travels he ends at 10 meters. So this dude, as he travels downwards just as much as he travels up. So his net displacement is 0. So when you add that negative area under the curve and the positive area, you got 0. Let's look at our last little graph here. Now we have the negative acceleration. This was our baseball that's going straight up with that upward velocity and then going straight down with the downward velocity. And the whole time, the force of gravity and acceleration are directed downwards. Velocity versus time for this. So this would be like an object that gets hit straight up and then comes straight down. So y units, meters per second, x units is in seconds, midpoint is going to be at seconds. So it has this big positive velocity right when you hit it. It has this big positive velocity. And then by time 0, it stops, right? Right before it starts coming down, it has to stop going upwards. And then by time 14, it has this big negative velocity. And if we connect those, we see we have a straight line. And the line is a negative slope. So let's put some of our points down. We had the big velocity to start, velocity 0 right in the middle, and then at the end, big negative velocity. And what does a point mean here? The point is the velocity at a given time. And what does the slope now mean? So our slope, we notice immediately that it's a negative slope. It's a downward facing slope. And slope for velocity time always means the acceleration. And the rise here is negative when you go down. And when you go over, you're going to the right. So that's positive. So a negative and a positive. The rise is negative. The run is positive. That's a negative slope, negative acceleration. So our acceleration here is negative for this velocity time. And let's look at our last little bit now. So now we got to look at what's the deal with the area underneath. What does this mean? And we know that the ball ends back where it starts, right? So it goes upward for a ways. And so it has this positive displacement. And then it comes back down. So it has this negative displacement. And the area, when we plug in units, we have base of seconds times meters per second, which is the height. Seconds cancel, you're left with meters. And the positive area, again, was the area when the ball is going upwards. It has that positive displacement. It's moving upwards. So by 7 seconds, it's as far away from you as possible. But then it starts falling back down towards you. And so that's negative. It's coming back towards where it started. The ball starts falling back down. So the total displacement here for this particular example is, when you add the positive and negatives together, is 0 meters. So the ball ends up right where it starts. That's what adding those two displacements together means.